Hello students, welcome to my channel. I am your Manoj sir. I hope you are all doing well. Let's start today's lecture, which is about the problems based on the reduction formula for integration over 0 to pi by 2 cos power nx dx. In the previous lecture, I explained the evaluation of integration over 0 to pi by 2 cos power nx dx. Based on that, in this lecture we are going to solve some problems. Let us start. And if you are watching my lectures at the first time, please do subscribe to my channel. Your one subscription will motivate me to do further beautiful concepts of mathematics. I hope you subscribe it. Let us solve some problems. The first problem is evaluate integration over 0 to pi by 2 cos power pi x dx. Let us solve this. Solution. Here you know that when we compare these two things, these two terms, integration over 0 to pi by 2 cos power nx dx and integration over 0 to pi by 2 cos power pi x dx, here n is equals to pi, right? So here n is equals to pi, which is odd integer, right? Then we know the formula, right? For if n is odd, we have the formula for that. In the previous lecture, I explained that. Okay, we did that. Okay, the formula is In is equals to n minus 1 into n minus 3, n minus 5, so on up to 2 whole divided by n into n minus 2, n minus 4, so on up to 3 into this 1, right? 1. Now we know that n is equals to 5. Let us write that I5 is equals to 5 minus 1, 5 minus 3. What is 5 minus 3? It is 2, right? So no need to write the further terms, right? Here the last numerator, the last number in the numerator is 2. 5 minus 3 is 2. So it's enough. Divided by n is 5. 5 into 5 minus 2. What is 5 minus 2? 5 minus 2 is 3. So no need to write this term, right? So into 1, right? Then I5 is equals to, what is 5 minus 3? 5 minus 3 is 4 into 5 minus 1 is 4 and 5 minus 3 is 2 divided by 5 into 5 minus 2 is 3 into 1, which is equals to, here 4 2s are 8, 4 into 2 is 8, 5 into 3 is 15, into 1 is 1. Okay, same. Here we get I5 is equals to 8 by 15. So this is a required answer. Then the next problem, the second problem is evaluate integration over 0 to pi by 2 cos power 6x dx. Let's solve this. Solution. Here we know that n is equals to 6, right? So n is equals to 6, where 6 is even integer, right? Where 6 is even integer. Okay. So when n is 6 or when n is even, we have the formula for that also, right? Right? Let us write the formula, that is in is equals to n minus 1, n minus 3, n minus 5, so on up to 1, whole divided by n into n minus 2, n minus 4, so on up to 2 into pi by 2, right? This is a formula. Let us apply for this. We know that n is equals to 6, that is I6 is equals to 6 minus 1, 6 minus 3, 6 minus 5, so on up to 1, whole divided by 6 into 6 minus 2 into 6 minus 4, so on up to 2 into pi by 2. That is I6 is equals to, what is 6 minus 1? 6 minus 1 is 6 minus 1 is 5 into 6 minus 3 is 3, 6 minus 1 is 1 into 1 divided by 6 into 6 minus 2 is 4 into 6 minus 4 is 2. Last term we get 1 by 2, here also 1 by 2. So into 5 by 2. Then I6 is equals to, here we can cancel out 3 ones are, 3 twos are, that is 5 pi divided by 8 twos are 16, 16 twos are 32. So this is a required solution for I6 for integration over 0 to pi by 2 cos power 6x dx. So this is a required solution. Then let us solve the next problem, that is third problem, which is evaluate integration over minus pi by 2 to pi by 2 cos power 5x dx. Let's solve this. Solution. Let in is equals to integration over minus pi by 2 to pi by 2 cos power 5x dx. Okay, cos power 5x dx. We can write this as by using the formula for property of definite integral. By using the property of definite integral, we can write integration over minus a to a f of x dx as 2 integration over 0 to a f of x dx for f of x is an even integer. Right? By considering this property of definite integral, we can write this as in is equals to 2 into integration over 0 to pi by 2 cos power 5x dx. Do you understand? Okay. Then here we know that n is equals to 5, which is odd integer, You know the formula to find when n is equals to 5 or n is equals to odd, right? We have the formula, that is in is equals to n minus 1, n minus 3, n minus 5, so on up to 2 whole divided by n into n minus 2, n minus 4, so on up to 3 into 1, right? Now we know that n is equals to 5, that is I5 is equals to 5 minus 1 is 4 into 5 minus 3 is 2, okay, divided by 5. Here also we have here, that is 2, right? So we have to write 2 here, okay, 2. Then here also there is 2, okay, then n is 5 into here n minus 2, that is 5 minus 2 is 3, it is enough, right? At the last we have to get 2 by 3, we already get 2 by 3, then into 1 is 1, the same thing, which is equals to here 4 into 2 is 8, 8 into 2 is 16, divided by 5 into 3 is 50. So I5 is equals to 16 by 50. So this is a required solution for integration over integration over minus pi by 2 to pi by 2 cos power pi x dx. Okay. Then the next problem is the fourth problem. Evaluate integration over 0 to infinity dx divided by 1 plus x square whole power 4. Okay, this is a fourth problem. Let us solve this. Solution. Here put x is equals to, I will put x is equals to tan x, tan theta. We will put x is equals to tan theta. Dx is equals to secant square d theta, right? Secant square d theta. Now, when I take x is equals to 0, when I take x is equals to 0, then in this x is equals to tan theta, then it will become 0 is equals to tan theta. Tan inverse 0 is equals to theta. Tan inverse 0 is 0, so theta is equals to 0. Theta equals to 0. Then x is equals to 0, we get theta equals to 0. Then I will take x is equals to infinity, x is equals to infinity, then infinity is equals to tan theta. Tan inverse infinity is equals to theta. What is tan inverse infinity? It is pi by 2, which is equals to theta. So when theta, when x is equals to infinity, then theta is equals to pi by 2, right? Let us substitute all these values in the given question, that is, let's take this as equation 1. In the equation 1, that is, okay, then in is equals to integration over 0 to pi by 2 secant square d theta divided by what is 1 plus tan square theta. 1 plus tan square theta is secant square theta, right? Secant square theta whole power 4, which is equals to integration over 0 to pi by 2 secant square d theta divided by secant power 8 theta. So this square and 8 cancels, that is in is equals to integration over 0 to pi by 2, that is 1 by secant 6 theta, secant power 6 theta d theta, right? The remaining part is this. Then in is equals to integration over 0 to pi by 2. What is 1 by secant? 1 by secant is cos, right? Cos power 6 theta d theta. Now it is in the form of reduction formula for integration over 0 to pi by 2 cos power nx dx, right? So here n is 6, which is even integer, right? Then you know the formula when n is even, right? So the formula is in is equals to n minus 1 into n minus 3 into n minus 5, so on up to 1 whole divided by n into n minus 2, n minus 4, so on up to 2 into pi by 2. That is, you know that the value of n is 6, so I6 is equals to 6 minus 1 is 5 into 6 minus 3 is 3 and 6 minus 5 is 1. Then n is 6 into 6 minus 2 is 4 into 6 minus 4 is 2. At the last we have to get 1 by 2. Here we get 1 by 2 into pi by 2. So I6 is equals to 15. You can cancel here. 3 ones are 3 twos are. Then 5 pi divided by 4 into 2 8. 8 into 2 is 16, right? 16 into, here also there is 2, 16 into 2 is 32. So this is a required solution. So this is a required solution for integration over 0 to infinity dx divided by 1 plus x square whole power 4. So this ends this lecture. Let's meet you in the next lecture. Until, take care, thank you, bye bye. God bless you.